In this video, we're going to investigate the idea of an inverse of a matrix, as well as ways to find the inverse matrix when it does exist. So as motivation, we want to consider what is the multiplicative inverse of 2? In other words, what number do we need to multiply by 2 to get 1? Well, it turns out 1/2 does the trick. And let's try to translate this idea into our study of matrices. So suppose A and B are n by n matrices, and they're necessarily square matrices with the property that the matrix product AB is equal to BA, which is equal to the n by n identity matrix. If this is true, then B is said to be the inverse matrix of A. And we denote B as A to -1. So I want to remark that not every square matrix has an inverse. And in fact, a nice criterion for if it does have an inverse is if the determinant of A is not equal to 0. So let's look at some ways to find the inverse matrix, given that we know it exists. So suppose that it is invertible, then we find it by row reducing this augmented matrix. You take A and you attach the identity matrix to it, and row reduce it to reduce row echelon form, and you get this other matrix B. Now this B here will be our A inverse. So in this example, let's try it out. So we have 3, 1, 5, 2, and then you put the 1, 0, 0, 1 here. And if you reduce this to reduce row echelon form, you will get first the identity over here, but then you'll get 2, -1, -5, and 3. So this will be our A inverse. Now, in a special case where we're dealing with 2 by 2 matrices, we have a nice formula for it. It's just 1 over the determinant of A times the D, -B, -C, and A. Where the original matrix was this A, B, C, D. And well, recall the determinant of a 2 by 2 matrix is just a simple product AD minus BC. So we can apply it here and notice that, well, we just take 1 over 3 times 2 minus 5 times 1, which is 1. And then we just flip those A and D to become 2, 3, and then this becomes -5, this is -1. So this checks out with this formula. And there you go. This is just a short video on the inverse matrix.